Hi guys, welcome back to the channel. In this video we are going to discuss the concept of multiplexer. So this is a very important concept in digital electronics and it is also part of combinational circuits. So let's get started. If you observe this is the basic block diagram of multiplexer. So we have total 2 power n the inputs and 1 output. So this is very important. And you have some select lines. So n select lines and 2 power n inputs. So based on this we can judge the output. So that is the general block diagram. So if you consider the one by one, so first if you see the two costs for multiplex, so it looks like this. So you have total 2 inputs and 1 select line and 1 output. So output would be always 1 for any of the multiplexer, but inputs will vary and select lines would be vary. So in this we have 1 select line and 2 power 1 means 2 inputs we can say. So in this case D0 D1 inputs, S0 is our select line. So if so we will see this working principles and motto of this circuit diagram. So but this is the block diagram I can say simply now. So not only that, multiplexer has two representations. So basic thing in this video we are just going to follow the first one, but we should know that this is also the correct representation of representing the multiplexer. So this is like somewhat trapezium type of representation you can see. So this is also correct. Following up, if you observe, this is the 4x1 multiplexer. So always output would be 1. Remember this thing, always output would be 1. So inputs and select lines would be vary. So in this case we have 2 select lines, means 2 power 2 4. So total we have 4 input lines, that is D0 D1 D2 D3. So we'll also see this working principle in this video only. But remember one thing, based on select lines only output or input will be selected to the output. Increasing one by one the select lines, the variable input lines also will vary. So if you observe, we have 3 input lines, so total we have total 8 inputs in this. So this is known as 8x1 multiplex. So you can also see the two forms of that. So we are going to use the first one in this video. So we are saying that is 8x1 because we have total 8 inputs and 1 output. That is the reason we are saying that is 8x1 multiplexer. So if you increase more, if you have 4 variables, then you have total 2 power 4, means total you can have 16 input lines. So how many the variable line input lines would be, but the output will be only 1. So that is why in this case. So how the inputs will be selected, or how we have to use the select lines for the selecting of output, so that's also we will see in this video. But the method is same for selecting all. So the 16x1 will be not going to discussed in this video, but the top 3 will be discussed in this video. But the procedure will be same for this also. So you can see over there, these are the 3 that we are going to discuss here, that is 2x1, 4x1, 8x1 multiplexers. In the first one, the 1 select line, second one 2 select lines, third one 3 select lines. So before starting in detail the 2x1 multiplexer, let's understand a quick something about MUX. So if this is also, so with NAND and NOR gates we can build a logic we want because those are universal logics. So we already discussed much more things about NAND and NOR gates. So we already know that is those two are logic gates, we can simply say. With the help of NAND and NOR gate we can build any of the circuit we want. So in the same fashion, so the same way we can build the MUX also in the logic because this is a universal logic. Because so what they are trying to say, so basically MUX is also universal logic gate. With the help of MUX we can build any of the logic we want. Suppose if you want to build the full adder or half adder or XOR gate, we have to build with the help of MUX. So we can build anything with the help of MUX. So we are going to see MUX implementation to form other gates, we will see in the other videos. So just in this video we are going to just discuss these 3 implementations, means these 3 just explanation of these 3 multiplexers. But in the upcoming video we also discuss the use or the implementation of, or the application we can say, as a universal logic gate of MUX. Again I am saying you can build any of the logic we want. You can build OR gate, we can build XOR gate, we can build the full adder, half adder, ripple carry adder, anything we want that can be built with the help of only multiplexers. So let's see a quick detailed explanation of 2x1 multiplexer. So if you observe there, you have 1 select line and 2 inputs, that is D0 and D1. So based on 3 means, if you consider this as 3, so you can draw the truth table as like that. So D0 D1 S0. So you already know how to fill from 0 to 7, that is 0 0 to 1 1 1. Then how the outputs are producing in the truth table. So if you observe how to take the truth table means, if you observe, if the select line is 0, we have to pass the Y as D0. If the select line is 1, then output would be D1, like that you have to see. So first case if you observe 0 0, So don't see the inputs, just see the S0. So if in the first case that is S0 is 0, so output would be D0. So check what is D0, that is 0. So if you check the next one, that is S0 is 1. So 1 means you have to select D1. So what is D1? That is 0. So output would be 0. So like that, if you take any case, if you take the last case, that is 1 1 1. So in that case S0 is 1. So 1 means what? D1. We have to select output in the format of D1. So what is D1? That is 1. So you will also clear more clarification can be get in the 4x1 multiplexer. So this is just understanding purpose. I have give full the table. So this full table is not necessary. So this has some shortcut table also. Let's see that shortcut table also. This is the shortcut table that I am speaking about. If you observe, just we need only two things, that is the select line and the output. Remember this thing, we need only two things, select line and output. So if you see the select line, that is 0, we are going to select the input as D0. So our D0 only, why? Because only one output means one output line, that is D0 only. So if you the select line is 1, we are passing S0 as 1. So output would be containing y is equals to D. So if you consider the final output expression for y, you are going to write in the SOP format, that is S0 bar D0 plus S0 into D1. Because if you observe the y expression, the first S0 is 0. So 0 means S0 bar and into D0 plus the next term is S0 is 1. So 1 means what? S0 only. S0 into D1. So I hope you are understanding, or you can relate with that truth table also, the output expression of the 2x1 multiplexer. If the variables is not S0, is if it's something as A, B, any variable, you can write in the output expression, because those are variables. But the logic is this, you have to represent in this format only the output expression. So for more understanding of 2x1 multiplexer, so these two are in the same, means the same thing, the same truth table I am showing, the first case and the second case. So if you observe the first case, that is I am passing 0 in the S0. So you are going to select, or the y is our D0. The next case, the select line is 1. So output would be containing the D1. So y is equal to D1. So I hope you are understanding this. So as we are selecting the data from the many of the inputs to only one output, so these MUX multiplexers are also known as data selectors or many to one circuit. We can simply say in many we are selecting one output, that is known as many to one. So instead of calling always multiplexer, so this have some shortcut name called, we can call it as also MUX. So simply we can call this as MUX. Remember this, MUX. So after getting the output expression for y, that is S0 bar D0 plus S0 D1, so we can also simply formulate the circuit diagram. I hope you know how to do that. So for the 2x1 multiplex, so let's see the circuit diagram for this with the help of the output expression. So this is the circuit diagram for the 2x1 multiplexer. So in the output expression we can see only one variable is there, that is S0, and S0 bar we can simply say. So with the line and with the help of NOT gate we can take the S0 bar also. So you can observe that we have two product terms. So for that we need to have two AND gates, and in between we have OR operator, means plus operator. For that we need to have OR gate. So I hope you know, in first thing we are going to pass D0, in the second AND gate we are going to pass D1, add both of the outputs. So finally we are going to get Y is as the output expression. So for the 2x1 multiplexer, so this is the final output expression with the help of circuit also. I hope you understand the 2x1 multiplexer. So let's quickly start the 4x1 multiplexer also. So if you observe there in the MUX, the 4x1 MUX, there are total 4 inputs and 2 select lines. That only we have discussed in the basic block diagram, in the general block diagram also. So if you see, the select lines are S1 and S0, and D0 to D3 are our input lines and one output line Y. So if you observe the shortcut table directly itself, you can see the truth table. So that is from generally 0 0 0 1 1 0 1 1, that is from going from 0 to 3, that is 4 total we know, because if you have 2 variables we can form 4 variable combinations from 0 to 3. So if you observe 0 0 means D0, 0 1 means D1, 1 0 means D2, 1 1 means we are going to select the input line as D3. So we can simply relate with the normal, so if you convert 1 1 to normal decimal, that also 3. So D3, 3 D3. So like that also you can simply compare the output expressions. So you can observe there are total 4 combinations, 4 possible combinations for that. So I have put in all the 4 combinations here. So 0 0 passing means D0 is selected, 0 1 passing means D1 is selected, 1 0 passing means D2 selected, and 1 1 is passing means D3 selected as output, final output. For bigger multiplexers, it is not possible to show all. So for the smaller circuits only, I am showing all possibilities. So you can observe, or you can proceed with the same logic that you are seeing here. If you have 3 select lines also, you are going to select based on the binary to decimal, decimal to binary. The simple things that you can know in your minds, and you can simply take out the outputs. Yeah, for the 4 cross 1 multiplexer also we are going to construct the output expression. From the output expression we are going to draw the circuit diagram also. So if you observe, y is equals to, we have first one, that is d naught. So d naught, for the d naught correspondingly the same row we have two variables, that is s1 bar and s0 bar. So multiply three of them and write in the output first term. In the second term we have d1 and s1 bar s0. So like that you can fill all the related with the 2 cross 1 multiplexer, and this is known as basic, known as SOP format. So you can write all the SOP formats and you can add all of them. So this is the final output expression for y for the 4 cross 1 multiplexer. If variables are changing, so write according to that variables. So you can clearly observe over there the y output expression. So output expression contains total, there are 4 terms or 4 product terms, I can say simply. So for the 4 product terms we are going to have 4 AND gates. So or adding all of them with the help of OR gate gives our final output y. So in the first AND gate I am passing d0, second one d1, third one d2, the fourth means the d3. Like that you have to pass all the inputs, and we have two select lines, that is s1 and s0. So in the output expression we have also the inversions, that is s0 bar, like that. So for that also I am going to take the variables, means the reverse one, that is s0 bar, s1 bar. With the help of the output expression we can simply join and we can have the output expression. So this is the circuit diagram for 4 cross 1 multiplexer. Basically we are representing with a box, but inside that box this logic whole circuit will be present over there, that we have to remember. So this is the block diagram, the truth table on the output expression for the 4 cross 1 multiplexer. So while I am studying I have some doubt, like what if the variable is changing, means the input variables. In place of d3 we have some d1, so up and down. So we have the order of the inputs from d0 to d3. What if the order is changed? We have from d3 to d0. So how we have to represent the output expression and how we have to construct the final circuit diagram. So this is a huge question in many of your brains. So let's decode how to get the output expression if the order is reversed. Order reversed or some random order if you might get in the exams or in the university exams anywhere. So just look at this. So this might be some random I took, that is d2, d3, d0, d1. So you can take from top down to top also, that is the 4, that is d3, d2, d1, d0. So you can take anywhere, but I took random way. For that question I have two answers. So first one, the according to the truth table that you have to decide. The second one is according to the question paper or the question that they have formulated, that we have to observe. If the question mentions that, so any of the random adder, but the corresponding minterms will follow the order like that they are mentioning or preferring in the question. You have to follow the first order. So first order is normal order that we have already saw. So wherever maybe the inputs present, we have to take the correct order, because the circuit diagram is designed like that. If the question mentions like that, if the question doesn't mention anything, those are just the variable names, means the tags. So according to that you have to follow the normal order only, the top to bottom order. So according to the input line positions, so if you observe that d2, d3, d0, d1, you are going to just follow the normal format rule, that is s1 bar, s0 bar, d2. So next one is d3, so that is s1 bar, s0, d3. Like that you have to proceed all the 4 variables wherever may be the present, from top to bottom, bottom to top, the random order, anything. You have to consider top to bottom. If they specially mentions they will follow the min terms correspondingly, you have to take that only, means you are going to follow the first rule itself. Otherwise it's just a tag that you have to follow from top to bottom. So finally there is the big thing guys, that is 8 cross 1 multiplexer. So by increasing gradually the variable terms, means the select lines, if you are increasing one by one, we are going to have that many input lines and we are going to have that much big output expression. So if you observe here we have 3 select lines, that is s2, s1, s0. So as there is 3 select lines, 2 power 3, 8 total, we have 8 inputs. So one output y, we already know one input will be there. So sorry, one output will be there in the 8 cross 1 multiplexer. So if you observe the truth table also, we are going to follow normal order from 0 to 7 and d0 to d7. So in the same format we are going to formulate the output expression. The first one, if you observe the d0 into s2 bar, s1 bar, s0 bar. So the next term would be d1 into s2 bar, s1 bar and s0. So likewise you have to fill all the remaining things, all the 7 means 8 terms in this, you have to fill output expression. So with the help of the output expression, I hope you know how to formulate the circuit diagram. So this is the thing. I hope you are understanding this. Thanks for watching up to now.